I'm Tim Ventura, here with Jeff Cook, who has worked on a number of gravitational and gravitomagnetic projects. Jeff is also just finishing up a new theory that he hopes will tie together relativity and quantum mechanics. Jeff, can you hear me okay?
Yeah, sounds great.
Oh, okay. Well, I should start out by asking you. You created the Jeff Cook device a while ago, and I tested that
hmm
and had some very interesting and unique results with it. I was using low power levels, and so it was hard to pin down exactly what was going on, but I was able to get a flame to diverge, and I was also able to get some very unique magnetic field configurations. I had a difficult time separating out magnetic effects from potential gravity effects, so I essentially wasn't able to make it to the stage of testing that I would have hoped to, but I walked away from it thinking that it was a very unique approach and a very unique device. And it was powered by 9 volt, which is just, incredibly low amount of power to get results from. So congratulations on that.
Well, thank you.
And,
I have
oh,
I have some newer versions of these coils that produce more consistent results. So, be happy to forward that to you.
oh, okay.
Also available on my Yahoo groups, electrogravity research.
Yeah. Well, I have several questions about your theory that I'd like
Yeah,
to
please.
ask. And the theory, I'm assuming, ties into both the research that you've done with magnetism and also some of the research that you're doing for a newer device as well, right? And
Correct.
and that's actually a device that produces thrust, but it uses different frequencies that overlap.
Correct.
Oh, could you tell me?
Purely RF energy and some plasmic potential. So, but its basic essence of it is producing two frequencies of typical RF energy, and one sent through the other. It creates a sinusoidal wave, which has immense power. If you've ever seen a lightning bolt, that's the power I'm trying to harness.
Oh, okay, okay. Now, you published a paper online that describes
hmm
some of the ideas behind this, and you had a lot of math in it. And I actually did see some feedback on the news groups, some of it positive and some of it on the negative side.
Correct.
But one of the things that we had talked about before the interview was that you had felt like the theory that you'd come up with matched with so many different experimental results that from experiments over the years that you felt like it was just a great theory in explaining a lot of these different effects.
Yes. Um, well, some of the controversy with the paper and the math is the carrying over of dimensions. And what I explain to these situations is when you're comparing two different energies or two different forces, you're going to run into some problem with the dimensions carrying over. The final question is if I have one formula that solves for gravitational interaction, which is the standard Newtonian gravitational interaction, and I have another formula that solves for the same results consistently, then even if the dimensions do not carry over properly, you must assume that somehow it's either dimensions we do not fully understand or it's the math we don't fully understand, but the solution is the same consistently. And not only can it solve for radial interaction, like between planets and suns, but it can also solve for centrifugal force of these planets spinning, and perhaps even between the moon and the Earth. There's some other anomalies going on with the moon that cannot be described radially. So there's another set of equations that need to be taken into account for, and if you're dropping the whole theory because of certain dimensions not carrying over, it's a foothold. It's standing in the way of progressing the science. I don't have a full explanation for why all the dimensions do not carry over. Most of them I do, but the paper carries over all of the dimensions fine. There's some question as to how uh, two waves of light can create matter, and they're questioning it mathematically. I hope that I can describe it in the paper, but the the results are the same for the standard math, and it's just a different way of looking for it that solves for the same thing and more.
Oh, okay, okay. In terms of, well, even in terms of light creating matter, conventional theory explains that in terms of, a high enough energy photon cruising along at some point may spontaneously, pop energy out of the ZPE field, and then you would have a proton and antiproton, electron and anti-electron. Where does conventional theory fall short? Because I tend to fall on the conventional theory side of things a little bit more.
I think they fall short in treating these as particles themselves. When you don't consider them as waves and measure them as waves, you start to lose sight of some of the dimensions that the universe, I think, really does function on. And I'm not the only one in this. There's de Broglie, not sure how to pronounce his name properly, but he's the expert early part of last century who showed that matter actually travels in the form of waves. And you cannot look at these particles, antiparticles, as individual objects with a radius in all circumstances. They may not have a radius. They may just be a wavelength. They still have the dimensions in distance, but they may not have actual spherical shape to them. And so some of the other equations that would work normally with spherical objects will not work for these, and they're having some problems measuring gravitational interaction between the atoms. And my paper describes where these things fall short. It's assuming that the proton must be in the center nucleus of the atom. My paper says is far outside the center. And measuring with Newton's gravitational interaction, you can see that the radius, which is why they say it doesn't make sense, the radius is far from within the Bohr radius. It's closer towards the circumference. If you look at it as just waves traveling in orbit to each other with two motions, one in an electric field, one in a gravitational field, you will get two waves traveling 90 degrees to each other. So the proton would be a wave traveling, let's say, up and down, and the electron would be traveling horizontally around it in the opposite direction. This is the standard motion that you can read up in plasma physics that describes this. If we drop the notion that it's actual particles, a lot of other answers come clear. That's where it's different from conventional physics.
Oh, okay.
Even though it's using elementary parts of other parts of physics, I just kind of look overall, so take a little quantum physics, relativity, and plasma physics, and piece it all together, and I come up with a completely different conclusion.
Yeah, it's definitely different in some points. Your new theory, you hold the opinion, I guess, that electrons can't exist outside the atom, and
Right.
that's interesting. I've read literature over the years, thermoelectric effects, where you can boil electrons off at high enough heat,
Right.
or just a large enough E field will kick a few of them out into space, at large enough voltages. But from your belief at least, the electrons can exist outside of the atom. Is that
Right. The formulas that I have suggest that its mass would, its energy would increase above its mass, and it would burn out. The exact opposite of what happens with a black hole. There's good evidence, physical evidence, that anyone can perform with simple experiments that would help explain this too. If you take, let's say, a balloon or a latex strap, and you rub it against polyvinyl chloride, which is a material they make winter coats out of, and you rub it up against it, create friction, you'll hear sparks flying, and in accordance with typical electrostatic, processes. And then you let go, it should cling to it properly, and it does. But if you take another balloon, and with the theory that I have just shed electrons off of this polyvinyl chloride and shed them onto the balloon, which is causing the interaction to occur, what it means is that because the charge of atoms between the electrons and protons must be equal, the polyvinyl chloride should be equally positively charged, and it should attract other objects. However, it does not.
Oh, okay.
So I can take another balloon and try to hold it onto that supposedly stripped area with no electrons, and it should cling to it, but it does not. There's other things too, like a light bulb. The standard theory for it is that it's shedding electrons, or boiling them off is the common term. And the question is, why then when you shut it off and you touch the filament, it's not positively charged? If it's shedding electrons, it should be giving you a little electric shock even when it's turned off from static electricity in the common notion, but it does not. Same thing with solar panels. If you have a solar panel in outer space, The photoelectric effect says that light coming in hits the panel and knocks off electrons, which induces charge in the electric wires. Why don't solar panels become depleted of electrons? Why
Well,
aren't they positively charged, when we touch them?
I'd always
They're
thought
not.
that I'd always thought that the overall electron, the number of electrons remained constant. It just traveled through the wire in a circular motion. Well, wouldn't that be the basis of just just magnetic fields generating electrical current in a conductor? Is that they don't actually remove or add electrons; they just change the position.
No, actually, the photoelectric effect suggests that the electrons actually are shed from the material itself. So with a solar panel, it's implementing the photoelectric effect. If it's just circulating electrons through, then why would a battery die? Why would a battery lose its charge? Does it suck electrons from one end of the battery to the other? I have a different explanation for this, and that is the separation and reconnection of electrical charges within the atoms itself. If you have material at one end of the battery and you hook up DC current, it is the process of connecting electrical charges within that, which eventually, when all of those atoms are connected, then it has no energy left. It has no charge. But you take a lead acid battery and you disrupt that balance with alternating current, you can recharge it and do it again.
Well, so what exactly is electrical current if it's not electrons traveling through wire?
Good. It's according to my model, it's a sinusoidal wave, which is very known in plasma physics, which is when you pass ordinary light through a non-dispersive medium. It takes on two frequencies. One frequency according to my theory, one frequency from the atoms itself, from their spin, and the other frequency of the light that passes through it. When this happens, the centers of gravity of the waves, or I don't want to say center of gravity, the center of their centrifugal force, share the same point in time. And therefore they must act as one wave, but they still maintain two separate frequencies. And it is this wave that travels through the electrical wire, and it is caused from the energy of the light coming through it, or the electrical charge from the battery, which is of the reconnection of these atoms, which is energy, and it's the same energy as a flame. What you're seeing as energy of a flame is the reconnection of atoms in the atmosphere. So if you are reconnecting once they're all done reconnecting, there's no energy left in the battery. With a solar panel, you have a constant influx of light, which keeps interacting with atoms, continuously creating the sinusoidal wave, which travels through the copper wire and is infinite as long as you have light continuously flowing towards it.
Oh, well, okay. To jump back for just a sec, you talked about static a few seconds before the last question. You were talking about static on different substances. A lot of people have said that static electricity or electrons or ions, what have you, might be the basis for ball lightning. And I've seen a lot of different explanations for it. Some people have said that it's just methane gas from swamps that gets charged. Although, if I remember right, that's also been the explanation for everything from UFOs to Bigfoot. So.
yeah, exactly.
Yeah,
No,
whenever
I have experimented, not extensively, but good enough to answer a few questions of my theory, and have been able to create ball lightning in two different ways, or in two different experiments using the same method. Way I create it is simply from passing one wave of light through another. The one that goes through it must be at a higher frequency, and therefore a smaller wavelength, and it goes within the other, like two springs passing through each other, or one spring passing through another. When this happens, their centers of their Larmor radius, which is a typical term in plasma physics describing the radius of the spiral path, they are sharing the same center point. They must then converge to become one wavelength, one sinusoidal wave. And when you do that, the velocity of one on the outside speeds up, and the one, I may have that backwards. One of them speeds up and one slows down, is all you really need to know.
Okay.
If you multiply them together, which is also a problem with passing dimensions through formulas, they equal the speed of light. So it has to be balanced in that sense. And it is this disruption of the energy when one wavelength passes through another that creates the plasma.
You know,
And
I've never
okay,
seen. I'm sorry. I've never seen ball lightning in real life. In fact, I think the most I've ever seen is a black and white photo. I don't think I've ever seen it on video. Um, but lots of people have talked about it. But you've actually created it, and I'd be
yeah,
interested
you can
in.
create it with a simple experiment. Just if you have a microwave that shoots the radio or the microwaves straight down from the top, and you place a candle, make sure there's no metal on the base of it or anything, but just plain wax and a wick. Set it in the center. Take out the rotary disc that spins it because it needs to be standing absolutely still because it's the trajectory of the two waves that's going to cause the interaction. So you send this candle on the middle, right underneath the waves, and the waves come down, bounce off the bottom, pass up through the flame, and you'll create some balls anywhere from the size of a golf ball to a grapefruit. And it has to be, not all microwaves do it. The microwave I have here at home is even heat system. It shoots it at 3 different angles. It doesn't work. It creates plasma, but it's not going to actually put it in the form of a sphere. Other microwaves do it, but it has to be the type that shoots straight down. And the flame, of course, will go straight up. And also, I wouldn't do it for very long because you might char the top of your microwave.
Yeah, I've played around a little bit with my microwave, although I've always tried to be safe with it because they can definitely hurt people. And I don't know if mine has too much power or what, but pretty much invariably something ends up on fire. And so that's the most I've ever gotten out of it, was no matter what I tried with it, something ended up burning in the microwave. So after a while I gave up. I got tired of scrubbing it out, and it always made my popcorn smell funny afterwards. So, you know.
Well, if your microwave's set up right, all microwaves work at pretty much the same frequency, but at different energies, at different voltages. So it's not going to happen, and if it's going to happen, it'll happen within 30 seconds. If it doesn't, if you don't see anything within 30 seconds, you could try somebody else's microwave, but I wouldn't continue experimenting on one that's not doing it right. Nothing should be burning up. The flame, actually, even after it creates the plasma spheres, the flame remains constant. It's just a normal flame of light. The plasmas, the plasmoids or the ball lightning actually are a product of the light itself. They have mass and charge, and the energy happens to be higher than the mass, therefore they'll float. But there are other ways to make smaller plasmoids which have more mass and energy, and they actually fall to the ground. But it depends on the frequency. If you have the trajectory right and everything else set up as I described, and it's not working, it's just the way the microwaves are being shot down in your microwave. And there you can try another one, maybe an older model or a newer model, depending on what you have.
Oh, well, another experiment that you've done is pendulum experiments, right? You've done a few of those, and those actually tie back into more of the classic Jeff Cook device setup,
Right,
right?
right. This is probably the best experiment to work with this coil because it is consistent. It does give evidence to the effects of the coil that are not magnetic. And what you do is you take a coil, and this coil is basically a hollow core, usually metallic, with a ferrous material, like steel wire wrapped around it, and then copper wire wrapped around it. It's like electromagnet wrapped around a coil of, iron wire. So there's a repulsive end of it, slightly repulsive, and there's attractive end on the other end. And you can check this with a flame. The flame will be attracted to one end or repulsive to the other. Once you find the repulsive, actually there's a way to know. It's the negative terminal going into the first part of the coil will determine the repulsive side. If you hang a pendulum, non-ferrous object, maybe of wood or brass, from a long chain, I use the swivel chains, pull cord that you find on lamps because they don't twist when they spin. And from a stationary arm, you give the ball a spin, and once set in motion, it will spin at a certain frequency, and no matter what diameter the circumference is, whether it's small circle or a large circle, or if it varies and goes in an oval, the frequency, the number of times it goes around in a second, is always constant. And so I've done many iterations with many different coils and compared the results. By timing it and measuring the circumference, you can measure the velocity, you can measure the frequency and the force of the coil itself, or the force of the Earth acting on these pendulums. And what it is definitely showing is that the larger the coil, the less force of the Earth effect on the pendulum. They will spin longer, they will spin at a wider radius, and at a higher frequency. And this frequency is different for every mass. I use different variety of pendulums, some plastic, some glass, some wood, and I time them all different. I find for one coil, each pendulum will spin at a different frequency. No matter how many times I do it, it still goes around the same number of times in 1 minute. And it's very consistent as a clock. It's as consistent as the pulsars, which is also a comparison I bring into the paper. It describes the frequency of pulsars remaining constant. This also occurs with other gravitational anomalies, such as tidal friction caused between the Earth and the Moon. The Moon will increase its orbit, increase its circumference, speed up, and its frequency, its number of times around the Earth in a day is always constant, or number of times in a month is always constant. Frequency remains the same. Velocity and circumference can change, and I describe this at the atomic level in the Pendulum Experiments and astronomical measurements too.
Well, it sounds like, between these two different sets of experiments, then I know you've done a lot of others also. It sounds like you've gotten some insights into maybe the way electrogravity works that other people haven't. And one of the things that I'd be remiss not to ask is, how's this stuff work? How does electrogravity work? At least, from what you've been able to see from your opinion and background. What should we be looking at, and what should the inventors out there be trying to experiment with to try and make things lift off?
It's the interaction between energies. Most people don't think that energy necessarily interacts. Most that are researching it knows that it does, but it is really the interaction between energies. The formula I use for gravitational interaction, this is actually from Jerry Bales' formula, which is one energy times another energy times permeability of free space divided by distance squared. That will equal gravitational interaction in newtons. The measurements will be the same. So the method to calculate in the gravitational energy of a spherical object is simple. It's extremely simple, and it works to the electron, it works to the Earth, the hydrogen atom, protons, and that's simply mass times the fine structure constant. That will give you the electrogravitational energy. With that, you can solve for anything. It's a simple formula, and it works in all cases.
Well, some people have been having difficulties with the dimensions of your math, and that's something I should ask about. That it's difficult to. I mean, I know they've been using MathCAD, which may not be the best all-around tool for everything under the sun, but do you have any thoughts on why some of these math formulas aren't working for them at least?
Well, that formula in particular, the problem is that most people think of the fine structure constant as a dimensionless parameter. It is nothing. They also consider c squared as a dimensionless parameter. But if you look at Einstein's work and you look at Jerry Bales, it's not necessarily comparing the two, but they both say the same thing. The fine structure constant actually has the dimensions mass divided by energy divided by mass, rather than it equaling meters per second, which is velocity squared. You can no longer consider it as velocity squared. It is considered energy divided by mass. But there's a lot of quantum physics has never fully integrated with relativity. Einstein's formula E equals mc squared can only be solved for if you treat c squared as a dimensional quantity, not as meters per second squared. Somehow the dimensions do not carry over properly and therefore cannot be used by the traditional method. However, it solves the equations. My math solves the equations. I just not totally disregard the dimensional aspects of it, but when they don't carry over, I sidestep that and look, well, what does this give me anyway? What is the end result? And the end result is that it's solving for gravitational interaction the same way. It's in fact more ways. So there's a long way we have to go with dimensional analysis. If something doesn't work in MathCAD, it's because it's not in its dictionary. It's like a word processing program saying that a word's spelled incorrectly because it's not in the dictionary. It's not going to work. To properly read this paper and understand the math, you really need to sit down with a regular scientific calculator or a pen and paper and really analyze it the old-fashioned way, the way the masters did it, the way before all these tools. The tools cannot replace fundamental understanding of the math itself. You really need to know what it's doing and look at the results, not necessarily always the dimensions, because we don't fully understand all the possible dimensions.
Well, one thing that I would love to ask is kind of maybe a final question is, I've seen your name a lot in the news groups, especially the news group that you run, right? And that's where people can get more information about you. And that's electrogravity research in Yahoo groups.
Yes.
And one of the things that I would like to ask is, I see these emails floating around, Jeff Cook this, Jeff Cook that, the JCE, but in terms of the next experiment, the next thing people should look for, when they're looking through the news groups, looking for emails, what do you think the next experiment that you're going to be working on will be? What do you think it'll focus on?
It will be, I am building a Siamese twin configuration of a magneton tube. I can never say it. Magnetron tube. So it's going to create two waves of light at separate frequencies and create a sinusoidal wave that will add thrust. So it's a new way of creating thrust without using fuel by creating its own matter in the form of plasma.
Oh, okay. Because, there were maybe 30 or 40 people that at least got to various stages of building the Jeff Cook device, the magnetic coil, a while ago. And it was a popular device, and still is, I think. There are still emails floating around about it. And so this is the next thing. This is what we should look for. And this is, hopefully, will help flesh out both your theory as well as maybe give us some new tools for propulsion research.
Yeah, this is what I'm hoping for. There is another project I'm working on. It's similar to the Searle effect. Did I say that properly?
Yeah, actually.
Sure. And except that it's using a combined effort between magnets and the coil itself. The coil creates a spinning field, and it's going to utilize that with the magnets itself. But I don't see that as the future of space propulsion because of the limitations on the mechanical structure of things spinning at such velocities. I'd rather spin the velocity of light and matter itself because the plasma will create a magnetic field. And so you still have the rotating magnetic field effect, which will create the anti-gravity solutions that all the way go back to Einstein. But to do that, this will be spinning a rotating magnetic field close to the speed of light, which is much powerful than we can do with conventional mechanics and ball bearings and magnets.
Oh, yeah, definitely. If you can go directly to the fields, it makes sense. Well, thanks again for your time, Jeff. And the news group,
My pleasure.
The news group is Electrogravity Research in the Yahoo groups. And I know I, for one, am definitely looking forward to seeing what's going to be coming out of your lab in the future. And, again, just thanks for the time and thanks for explaining the new theory to us.
My pleasure.
Well, have a good one.
Thanks, you too.
Bye.